Today, I'm going to give you a sneak peek into some of the projects that I am developing. I've created several demos just for this particular video, but really we just use machine learning and artificial intelligence to create applications for environmental monitoring and for specifically for aseptic processing. The current approach and the way many challenges are solved within the aseptic environment is heavily dependent on either human capital or possibly mechanical solution, usually, some type of sensor data or a PLC that is making decisions about what happens next to either a product or to a component during the processing. We're very heavily dependent on these methods because they've proven reliable over time. But as technology progresses, we find that there are nearly unlimited applications for machine learning and AI, and we can solve many of the problems that exist today that mechanical and sensor type solutions cannot resolve. I've built some programs here to show or demonstrate exactly, what specifically is going to be impacted or could be impacted going forward. But just remember, this is not a comprehensive set. This is only a few highlights associated with both machine learning and artificial intelligence. I'm going to come back to this video and how I produced this in a later slide, but it just gives you an idea of how computer vision can be of service. Here are some use cases that machine learning and AI will most likely tackle first. I know because I'm working on some of these right now myself. For example, you want to determine if a TSA plate is present or absent inside of the microbial impactor. Well, you can acquire that information. You can also see whether or not the lid is either open or closed on the particle counter, and that can be visually assessed. You can check how many interventions you had. You can track or count the number of people that are in a room. You can read moving barcodes. And I don't just mean down a conveyor belt. I mean barcodes that are being moved throughout the laboratory. So you can track that type of thing with machine learning, specifically with AI. And think about the dimensional analysis component, which is root cause analysis, which we'll talk about at the end. There's a long list of some of the challenges that led to 483s in fiscal year 2023. 2024 is fast approaching, and I suspect that many of these challenges have baked into the observations that have occurred in 2024, but we'll soon find out. We used natural language processing to review all of the records associated with drugs in 2023. Now you'll notice that there's 510 records for drugs specifically, but the total number of 483s is about 4,428. So those are a lot of records. I couldn't review every single one of those if I had unlimited time to sit down and read them all. I don't think I would make it through the rest of this year or the following year. I'd be reviewing for better half of my life. However, um, with the use of natural language processing, we can actually look at every one of these records if we wanted to. I decided to focus on the drugs, and I'll show you what high level look at some of the results were. I use a technique called natural language processing. And what that's able to do is review all 510 of those records, and it pulled out the highest frequency words. You can see procedure, batching, component, and equipment are all very, very large. So is the word record. And so they occur quite frequently inside that document. But there are some that I highlighted here which are very closely associated with microbial and total particles, as well as environmental monitoring. So you see contamination, sterile, you see quality control, you see cleaning, and there's a few others. If you pay attention, you'll see that there's others that are also in here. Um, Natural language processing goes beyond just being able to review these 510 records. We can actually process voice information. You can also review entire batch records, even where people have used handwriting. So, for example, you have to line an item out, sign and date, put in a recent code. Well, natural language processing can review all those records to make sure none of that stuff's missing. So you can imagine how much faster the review process would go in quality assurance, quality control. Traditional computer vision techniques rely on a lot of sort of dated approaches in terms of how computers determine what's in front of them. Edge detection and sort of a topographic map of the image itself is really what's built up in some of these older techniques, and they do work, but they're the equivalent of having Braille um, versus being able to see the words and reading them on paper. I mean, both techniques can be effective. It's just that with computer vision, we actually break free of so many limitations. So, as an example, you can see that all I did was I took a high definition picture of an auger plate, and I loaded it into my computer model, and the model went and assessed how many microbial colonies are there. No big deal because there are automated bacterial and microbial plate readers as well. But you'll notice that it even picked up the Sharpie, right? So it's classified that as a different type of object. And this is really where the artificial intelligence it sets itself apart. So it's doing is it's classifying these different types of objects, and we can design it so that easily optimized so that we get 100% visual acquisition. So for example, you see the bottom left did miss that second Sharpie there. And that's just because I put this model together very, very quickly. I didn't really do a whole lot of, off feature optimization or anything like that. I just wanted to demonstrate how easy it was to make this particular type of product. So there's the beginning image. I just drop the file in and boom, it acquires. The big question is how fast can this be done? Because remember, you're not reading one plate at a time. Maybe reading, 30, maybe more in a single sitting. So let's see how quickly we can acquire. So although this is not, a controlled space, what I'm showing is that with computer vision, I can actually acquire many objects at the same time and I can determine what they are while they're still in motion. So that means that if I had, dozens of auger plates, I could put them on either some type of conveyor or, Rolodex system, and we can then count all the colonies very, very quickly, and they could go right back into their incubation chamber, while the computer has already assessed all of the colony counts. So this just gives you an idea of just the range associated with computer vision. Of course, the limitations are hardware limitations. I mean, how good is the camera? How fast is the processor? How many images do you want to classify at the same time? Hopefully, you're never in a situation where you need to capture this many images inside of a clean room, but it just goes to show you that, if a human being had to do this, the task would be essentially impossible. I had and decided to put together a little program. And I wanted to see, can we detect that there's no mask? So you can see that there's no mask and there's an alarm going off saying that there's in fact no mask. So once the mask is placed on, that alarm is silenced. And that's actually pretty nice. But I decided I was going to take it to the next level. And I decided I wanted to acquire the mask. And after I acquired the mask, I wanted to be able to detect that there were goggles as well. So now I can see that there's mask and goggles. And of course, then I built up the application to see, well, can we detect the full range, coveralls, face mask, gloves, and even the operators and see what they're doing. So that was really the full process. And in terms of me progressing this particular program along, start off very simply, and then of course it becomes more sophisticated with each level. We can incorporate this into the environmental monitoring system, and we can use this to do things like, you know, how many interventions you have. We can look at the auger plate and see if it's actually located inside of the atrium or the uh, the microbial impactor. We can tell you if the lid is closed on the particle counter, and we can even track different types of equipment. So we can say that, in fact, there is no uh, microbial impactor in place, or that there is a microbial impactor in place. So there's a number of different applications we can apply here to environmental monitoring, and you'll be seeing those come through in upcoming updates. New technology is fantastic, but It really boils down to, can these systems be validated, and can you have, accuracy? Can you have reproducibility? And how can you prove or demonstrate that? Well, that's the beauty behind this type of system. Once we create these types of machine learning models, we can look at, and this is really the heart and soul of what the validation would look like for this type of, product. We have a confusion matrix. And inside the computer fusion matrix, what we see is, on the left side, predicted values, and across the bottom, you see true values. So we predicted that we would see a certain number of coveralls, and we saw how many coveralls. Well, I've normalized this data set, so you're not seeing number, you're seeing a percentage. So 87% of the coveralls that were there were predicted. So we predicted 80, the only 87% of the total number that was there. Well, in that same, you know, term of prediction, 13% were classified as background. Now that doesn't sound very good, but it's actually excellent for a project that, took, I don't know, 4 hours to make. There is feature optimization where you can improve these numbers, get higher and more acceptable percentages. I personally think that for pharmaceuticals, you probably need 97% or more, because you still need some generality. 100% would be unacceptable. 100% would be root memorization. In other words, it would memorize which garment is physically in that room. And that doesn't make sense. That's overfitting the model. We don't want to do that. But because so many things in pharmaceuticals are highly consistent, they're done exactly the same way every time. I think something like 97% would be acceptable. But that may be a subject for debate. But you can see some of the other areas. Maybe it didn't do so well with goggles, face masks, not so well as with coveralls, but it did pretty, decently with coveralls, and not so much with face shields. And again, we can optimize the model so that we have better numbers. The other application of machine learning is its ability to do things like regression and classification. And if you think about what happens when you acquire data in environmental monitoring, you may have particle counts, microbial or total particle, and you can put those into histogram. That's easy enough for the human brain to understand. You can then take that data from, particles or microbials. You can trend that over time. And again, those are two-dimensional data sets, are easy for us to determine and understand. But once you get to a three-dimensional data set, so maybe, for example, you take the total particles and the microbial, and you want to graph them both onto the same graph. So you're going to have, three-dimensional data, and you want to analyze this data. Oh, you could draw this, and you could potentially, get some regressors out of this and generate some type of information associated with it. I mean, it's not impossible. It just is more confusing a task than, say, a trend analysis. But once you get beyond three-dimensional data, you get into four, five, six higher dimensional data, which I refer to as n-dimensional data analysis. It's impossible to really depict this visually, but it's even harder for a human being to sort of figure out how to manage this type of data mathematically, quantify it in some way. And this is where machine learning come in. It can take all of these different types of variables and then actually reduce them to single individual dimensions, and make it very easy for us to not just visualize, but also project and show which direction things are moving in. So we can help with investigations, 483s. We can do all types of preventative actions, corrective actions, and all as a result of this multi-dimensional analysis. And that's really the power behind machine learning. If you think about how we solve many of the problems we have today, a lot of it is based on, we do have data that we take, and we process the data, and we try to figure out where the data is leading us. But at the same time, one of the reasons we have so many experts available in the industry is because their experience and their intuition helps lead them to the correct position. Well, I would wager that, with the correct machine learning program, experience and intuition would be easily matched against the dimensional analysis of machine learning, provided that the data set that we use to train the machine is a good data set. How would a lot of this look in real time? Well, you gather information from sensors, batch records, you get information from microbial and total particle counters. You would gather information from personnel while they're moving through the lab, number of interventions. You would get microbial counts. You would take any type of historical trend analysis, and you'd put that all into your machine learning model, and then you can do things like risk analysis, corrective action, preventative action, tackle observations. You could do training with this. You could do all types of things to address compliance needs. It just depends on how the system is designed. Thank you for joining me. Pauldron is a multidisciplinary team of industrial regulatory experts. We specialize in aseptic processing, environmental monitoring, and of course, we provide comprehensive solutions for regulatory compliance, technical services, and provide global support for FDA, EMA, and of course, local authoritative standards. Just some of the services that we provide, compliance and response, analytical services. But today we talked a little bit about machine learning and AI, and those applications are also available. But if you want to know more, please feel free to contact us. Thank you.